Okay, so in this video we're going to look at completing the square, the boogeyman. This is one of the most notorious concepts in all of high school math. Everybody hates this. Nobody knows how to do it or wants to do it, but this is one of those things that doesn't go away after high school. You need to know how to do this in university math. You're going to be expected to know how to do this coming into first year, and it's really not so bad. It's really straightforward if you think about it properly. Like so many things in high school math, it's taught wrong, and it's needlessly confusing. So we are going to get to the bottom of this here and now. We're going to see a different way to complete the square, to think about completing the square, which is probably not the way you were taught, and which will make a lot more sense, and then you'll never have any confusion or anxiety about this ever again, and everything will be wonderful. Okay, so to begin with, suppose I have this quadratic in the y is equal to ax squared plus bx plus c form, the standard form, and I want to put it into vertex form. This is the vertex form of the quadratic. And if any of this seems a little bit weird, please do check out the playlist on quadratics and the different forms, and how to graph them and everything. We're going to review this very quickly, but we're assuming that you know all that stuff coming in. So I want to get it into vertex form. Why? So that I can find the vertex, surprisingly. I want to find the x coordinate, the h coordinate of the vertex, which is going to be the value, the input value that gives me, and maybe I'll do this in pink, that gives me the maximum output in this case when it's facing downward, which is the y coordinate of the vertex, or the minimum output, the minimum y value, if it's an upward facing quadratic. And I want to do something to this standard form so that I can get it into vertex form. I want to start with this and end up with that, and that's what completing the square is. It's a tool, the tool for doing this. And before we look at how to do it, I just wanted to observe to begin with that the A's here are the same color. They're both the same pink color, and that's not a coincidence. This is in fact the same A. The H is not the B, the K is not the C, but the A's are absolutely the same here. In case you were wondering about that. All right. So how am I going to turn the standard form into the vertex form? The key is noticing that the vertex form has this perfect square term here, this x minus h squared term. And I'm going to do a trick that allows me to consolidate that perfect square term and get rid of the x. The problem here is that I have this x term there. I want to add something to this bit so that it will collapse into this perfect square term here, the x minus h squared, and leave me with just the k, just the y value of the vertex left over. And so the idea is I need to add the right thing, and there's a little trick. We have a video on where this trick comes from. If it seems a little bit random here, we're just going to see how to use it. But if you're curious, and hopefully you are curious about how someone would have figured out how to do this, please do take a look at that video. So the trick that I'm going to do is I'm going to add b squared divided by 4a, and then I'm going to subtract b squared divided by 4a. And this is a math trick, which I like to refer to as sneaky zeros. I'm going to add 0 in a sneaky way, in a way that helps me. And adding 0 doesn't change the equation. So it's just going to allow me to re-express the exact same thing, but now in a way which allows me to see that perfect square term, to break off that kind of perfect square term and collapse it into that a times x minus h squared thing, which I have down here. And this is a very common and important math technique. There's also sneaky ones, which we talk about in other videos. But that is the trick. That's the idea. And we'll see where, again, in the concept video, the one that goes into a bit more depth on this, where that came from, how did somebody think of this, but here we're just going to see why it works and how it actually gets you the right thing. And we're going to move this down a little bit so that we have some space to work. So, okay, I'm going to rewrite this. I'm going to write this as ax squared, or not a squared, ax squared, let me just redo this as a mess, ax squared plus bx, now plus b squared over 4a, and then plus c minus b squared over 4a. So what I've done is I've added and subtracted b squared over 4a. So that's like adding 0, right? It hasn't changed the equation at all. It's the exact same thing, except that this bit here is now a perfect square. This is, in fact, the square root of a times x plus b over 2 times the square root of a squared. How do I know that it's that? Well, if I have a perfect square term, if I have say like x plus y squared, after I FOIL this out, I get x squared plus 2xy plus y squared. So if I know that this is a perfect square, then when I collapse it, when I go in the opposite direction, I know that the first thing here, the x, it has to be the square root of the square term there. And what is the square root of ax squared? But square root of a times x. And then what about the other one? I'll just keep this because it's already highlighted in green. The y term has to be the square root of the square term there. And then you have the plus 2 times xy in the middle. So what is the square root of b squared over 4a? It is b over 2 root a. And again, we added this term specifically because it was going to give us this perfect square here. It specifically was going to give us with this ax squared and the bx fixed, while adding b squared over 4a was going to turn that into a perfect square term. And then we just kind of accept that this is the other stuff that we're left over with. Okay, so that's great. We now have, and I'm going to move this down once again to get out of the way because we're running out of space here. Just bear with me 1 second, and there we go. I'll line it up on the axes. Great. Okay. So we get to this, and I'll erase this because it's just going to be distracting. Sorry. There we go. Okay. So I have this perfect square term plus this remaining stuff, this b squared over 4a, and this bit here, this is my k. This is the y value. This is the k down here. Let me highlight this in the same. Maybe I'll make it like pink. This is my k term. C minus b squared over 4a is my k term. All I have to do is clean up this bit. I have to get this a factored out and make this look like my which I'll actually move up, vacillate a little bit more, move up here, my x minus h squared term, because that once I've isolated it, that will give me the h, the x coordinate of the vertex. And the way that I do that is just by saying, okay, what if I factor out, because the coefficient of the x here is 1, what if I factor out that root a from the x? And this is a step that people typically find a little bit confusing, so we're going to do it nice and slow and explain it as we go. What if I factor out the a? I'm going to have now x plus b over 2 times a. And why is it, and let me add in the rest of this. I'll just bring this stuff down. Why is it a in the denominator? People sometimes find this confusing. Well, the reason is that a is equal to the square root of a, or a is equal to the square root of a squared. So when I multiply in this root a, I need to have a root a. I need the 2, of course, and I need to have a root a and a root a to cancel. So when this gets multiplied in, it hits the x and becomes that root a up here. And then when it hits that root a squared, I'm going to be left with that root a up here. So that is why there's going to be an a in the denominator. So, and let me get rid of this and just put that back in to a here. And then of course now I'm left with this term out front, this a here, or this root a here, and that is being squared, right? This is the square of a product, so I'm squaring both of the things inside the brackets, and I end up with, well, square root of a squared is just a, and then times x plus b over 2a, and squared, and then plus c minus b squared over 4a. And this is it. This is it. I have put this into vertex form. I have my h here, and I have my k here. Actually, let's keep the colors consistent. The h and the k. This makes it clear. This makes it clear that h is not b over 2a, but negative b over 2a, and the k is c minus b squared over 4a. This is the k term. So and that's it. That's completing the square. The only thing to keep in mind is, and hopefully everybody noticed this and was shouting at the screen. Wait, what about what you did up here? That's a little bit shady. I took the square root of a. Hopefully everyone noticed this, that I collapsed this and said, Well, this went from being ax squared plus bx plus b squared over 4a to being square root of a times x plus b over 2 root a squared. Well, that assumes I can take the square root of a, right? That assumes that a is positive. And people were saying, well, what if a is negative? Can you still do this? And the answer is no. But you can just factor out the negative from the whole thing. So suppose I started out with a being negative, right? So a is equal to, like, I don't know, -2, right? And I have y is equal to -2x squared, say, plus 3x minus 5. Well, what am I going to do? I can't take the square root of -2, but I can write this as, I can factor out a negative and write this as -2x squared minus 3x plus 5. And then I can go through the exact same process using this 2x squared minus 3x plus 5 here, and do all of this stuff, taking the square root of a, getting my nice formula down here, my completed square formula, and then at the end, whatever I have, I just multiply it through by this -1. Just don't forget to multiply back through by -1. And this, by the way, is why in high school they typically do this really confusing thing, which is, I think, the primary source of confusion with this for most students, is that the first thing they do is that they factor out the a from, I think it's just the first two terms. They write this as a times x squared plus b over a x plus c. And then they add a different thing. It's not b squared over 4a, and that really trips people up. And the reason they do it is because they need to get rid of, if you get rid of this a, right, you factor out the a, then in here the x term is going to be the coefficient of the x is 1, so it's positive, and you can take square roots. You don't have to worry about that. But this complication, this added little complication, really messes with people. This really causes a huge amount of confusion, which is why I mentioned at the beginning we're going to be doing it a different way than they typically teach in high school, and this is it. So hopefully that was a little bit less confusing than the way that you learned it before, and hopefully this all makes perfect sense. We're going to do a ton of examples of this. So, but please do me a favor, and before you move on to the examples, try to do these calculations for yourself. This is the key to really understanding stuff like this, is try to go back through this, right? Start with the y is equal to a times x squared plus bx plus c, and try to derive this formula for yourself. And if you really get stuck, come back and take a look at the video and then pause it and go back to it. But make sure that you can actually work out these calculations for yourself. The test for whether you understand something is always, could you explain it to someone else? And so once you've understood the process, you don't have to memorize anything, by the way, anymore. You know why it's going to be the b squared over 4a that you're adding and subtracting. It will make sense, and it will be really hammered home and it will sink in properly. You'll never have to worry about it again. And then you actually really have that deep understanding. And then moving on to the practice problems is a good idea. If you were to do that before, right? If you didn't have that deep understanding and you just said, okay, I'm impatient, I want to get straight to the practice problems, you're not going to benefit in the same way. You're going to find it more confusing, more stressful. You really want to make sure that you have the concept down before you reinforce it with examples.